We saw Kramer's rule for 2 by 2s yesterday. 2 equations and 2 unknowns. It doesn't matter what's 3 equations, 3 unknowns, 4 unknowns, 5 unknowns, 6 unknowns. As I said, when I took physics, it was not unusual for me to be using Kramer's rule on 5 equations and 5 unknowns, because some of the physical systems end up being that large. When you've got all these components, you've got to figure out what size each component has to be. And so at which point it doesn't matter if I add another one, it would still be the same. So if there was an x, y, z, w, w would be the d sub w over d. So it operates just like the 2 by 2. X is d sub x over d, y is d sub y over d, z is d sub z over z, where d sub x is d itself, and I don't have d here, d itself is the determinative coefficients. So I'm going to put d here, and what d would be a11, a12, a13, a21, a22, a23, a31, a32, a33, and it's the determinant of coefficients. So what it says is you take the determinant of coefficients if you're looking for x, replace the column that represents x by the constants. D sub y is you take the determinant of coefficients, remove the column that represents the y value at the coefficients of y, put in the constant column. D sub z is you take the determinant of coefficients and then essentially replace the column representing the coefficients of z by the constant column. And then you only need to do d once, because then it's d sub x over d, d sub y over d, d sub z over d. And the first thing that I do is I essentially calculate out all the determinants. I calculated out d, d sub x, d sub y, d sub z, how many I have, and then I calculate out the final, which is x, y, and z, once I have the values for all the determinants. So in this case, d itself, it's the determinant of coefficients. So it's 1, 2, 3. This guy has to be really accurate. Minus 1, minus 3, 1, and 1, 4, negative 2. And then cross-check this. I'm going to go across since I went down. 1, negative 1, 1, 2, negative 3, 4, 3, 1, negative 2. And you say, well, why do I want to be really careful about that? Because this is a guy then I'm going to use to pull a column out and put a column in. So this guy had better be right, because otherwise it's going to screw everybody else up. Now, d sub x, because we're doing everything on our calculator, d sub x takes the column representing x and puts in the constants. So I'm going to change pen colors here. The constant is negative 4, negative 15, 12, and then that column goes away, everybody else stays. Negative 1, negative 3, 1, 1, 4, negative 2. D sub y now takes out the column that represents y, puts in the constants. So 1, 2, 3, column is negative 4, negative 15, 12, 1, 4, negative 2. And then d sub z now takes out the column representing z and then puts in the constants. 1, 2, 3, -1, -3, 1, 1, 4, -2. Oops, what did I just do? I didn't change pen colors. That's another reason why I cross-checks myself, right? I didn't change pen colors because when I change pen colors, that's my new column. So this is -4, -15, and 12. Now I get to calculate out all of these determinants. And you're going to say, well, why? Because x is going to be equal to d sub x over d. Y is going to be equal to d sub y over d. And z is going to be equal to d sub z over d. So now I need the numerical values. So first thing I'm going to do is calculate out D. So second matrix, and then I'm going to edit, and it's going to be a 3 by 3. A is a 3 by 3. You can see I've been playing with this already. And this is 1, -1, 1, 2, -3, 4, 3, 1, -2. So again, I'm going to cross-check this to make sure it's correct. Come back out to the home screen. And now, where is it? It's in A, right? So I either have it in memory. For those of you who have it in memory, you can pull out determinant of A, because we did that yesterday. Or reminding you, you do second math, not second math, second matrix, math, and then there's DET, that's determinant. Where is the determinant? It's in matrix A. And it's -3. So that says the denominator of each one of these is going to be -3. Now you can do a couple of things, and it depends upon how sophisticated you want to get. And that is, I'm going to use the same matrix, but I'm going to replace the first column by the constants. So back into matrix, and in A, and the first column's now going to be -4. Now you can use your down arrow, by the way. And -15 and 12, because everybody else remains the same. And now you do the same thing. Go back to the home screen, and now what are you going to do? Determinant A. Just pull it back in. Second enter from memory, and it is -5. Now I know what x is. X is -5 divided by -3. Here we go, same thing. Second matrix, and then edit. And now what do I have to do? I've got to try to put everybody back in place, right? So the first column goes back to 1, down arrow, 2, down arrow, 3, enter. And now the second column becomes -4, -15, and whoops. See what happens? I'm so used to pressing enter. So this is going to be 1, -1, and 1. I got to put this guy back in place. 2, and then the -3 is going to turn into a -15, and then down arrow, and 12. And if I haven't screwed up, let's pull the determinant back in, And it's negative 13. You guys get negative 13, I hope? Okay. Now I know what y is. It's negative 13 over negative 3. Now, same thing, second matrix, edit. Now I've got to put back in place negative 1, down arrow, negative 3, down arrow, 1. So I'm back to my original matrix. So now the next column is negative 4, negative, oh shoot, did it again. That should be a 2. That's now a 2. That's still a 2. It doesn't like something.
It's because you have it down for 2, you have it down for a negative sign.
Oh, that's white. Okay, thank you. Couldn't see it for looking. Okay, 2 and then negative 15, and I'm just such a creature of habit. The down arrow just drives me crazy, so. All right, now we're ready again. So second matrix, I don't need to do that again. So second enter, I get out of there. Second enter, pull back determinant. 4?
Yep.
Okay. So what is x? X is d sub x over d. So it's 5/3. Y is d sub y over d. Now this is a problem I would not want to work by hand. Right? And then this is d sub z is 4 over negative 3, which is negative 4/3. Can you imagine what that would be like if you wanted to reduce that thing down? By hand? Lots of fractions. And there's no way to avoid them.